It says Risky Inc. wants to lure Sarah away from Small Limited to head their finance department. So freeze, first we identify that this is a moral hazard question because it's talking about trying to take an employee from her other job to our job. And then it goes on to give us her utility function is some function of wealth minus C, which C is some cost of effort, and the effort is unobservable and uncontractable. It tells us the cost of effort is 0 if Sarah does not work hard, and the cost of effort is CH if she does. It says Risky Inc. will make high profits with probability F if Sarah works hard and 0 if she does not. It doesn't tell us about G. It doesn't tell us about the probability of high profit with low effort, so we're going to assume that that's 0. It also doesn't tell us the cost of effort at her other job, but we're also going to assume that that's 0. It does say let CE stand for the certainty equivalent of wealth of Sarah's job at Small Limited. So CE, again, thinking back to the insurance problems, that was some single amount of wealth we'd be willing to accept for our gamble. Here it literally means our reservation wage. CE literally means the amount that we're paying Sarah, the amount that the other job is paying Sarah right now. It then tells us to define WL as the payment if profits are low and WH is the payment if profits are high. So profit is our signal. And what we notice is there's no actual utility function, there's no numbers. He's leaving everything in notation form. And this confuses a lot of people. This is scary to a lot of people, but I promise you it's not that hard. You just have to remind yourself what this problem is all about. Think about it. Think about other examples with numbers if that will help you to set it up. But just leaving it in notation form should not be that hard. You just have to practice. And let's take a look at the question. It says, which of the following describes the solution to Risky's contract design problem? And we notice our answer choices are all very weird looking notation. So we're just going to do what we know. We know we need to write a participation constraint, and that participation constraint is going to say working hard at our job is going to be equal to her other job. Again, F was the probability that we'd actually make high profit, and then she would consume that high wage and get the utility of the high wage. 1 minus F when she's working hard is the probability that we make low profit and she consumes that low wage and gets the utility of the low wage, minus the cost of her hard effort has to be equal to the utility of the certainty equivalent. Because again, the certainty equivalent was her reservation wage, and we need to find the utility of that reservation wage for the participation constraint. The selection constraint, well, it looks the same on the left side. And on the right side, since we already said we're going to assume that G is equal to 0 and the cost of low effort is 0, we know with 100% certainty we're going to make our low wage, so we're going to have the utility of our low wage when we shirk at our job. And working hard at our job is going to be the same thing. So if you think back to other problems where we had actual numbers, this kind of looks familiar. And we see that we can conclude that U of CE is going to be equal to the U of WL. Or further, we can conclude that our low wage is going to be equal to our certainty equivalent. So just because, again, both of these left sides are the same, the right sides must therefore be equal because we're equating both of these equations. So from here, we want to go ahead and plug back into our participation constraint what we know is equal for WL. So we plug CE in for WL. And the only thing I can see to do from here, this is the right answer, but it doesn't match one of our answer choices. We just need to manipulate this thing. We just need to use algebra and cancel things where we can and make this look prettier. So the only thing I see that we can really do at first is distribute this 1 minus F out to the UCE. So that'll give us, well, the 1 times the utility of the certainty equivalent will just give us the utility of the certainty equivalent, minus F times it will give us this. And now we notice that we have a UCE on this side and a UCE on this side, so they can cancel. And when I look at my answer choices, I notice that I have a positive CH on the right side, so I'm going to add that to both sides. And I also have the utility of my certainty equivalent on the right side, so I'm going to add that. And of course, F is multiplied by that, but I see I can divide everything through by F and get one of my choices that I see on the test, which is the utility of my high wage is going to end up being equal to the utility of my certainty equivalent, because the F's will cancel, plus CH over F. So kind of a long process, but if you remind yourself that this was the work, this step was the work, setting up the participation constraint, setting up the selection constraint, substituting what you know about the selection constraint into the participation constraint, that was the work. From here, it was just algebra. They do look confusing. The answer choices are intimidating. But if you tell yourself, I know that I'm setting this up right, it'll only be a matter of time until you find an answer choice that you can solve your equation down to. So the next question says, let the amount in excess of the certainty equivalent that Sarah would have to be paid to compensate for the disutility of high effort be represented by VH. I know that sounds confusing at first, so let's not worry too much about that right now. We are going to be using VH. We see it all over our answer choices, and that is kind of the hard part of this question, is defining that properly. But let's go on to read what they're asking for first. It says, which of the following represents the extra expected wage cost incurred by Risky to hire Sarah and motivate high effort due to the presence of uncertainty and moral hazard? So if you remember in the problem set question and other test questions, when we found the extra cost associated with moral hazard, or another way to say that would be how much lower would expected labor cost be with perfect information. Those are saying the same thing. It's just the difference between our expected wage with uncertainty and our wage with certainty. Both of those we can say how much lower would expected labor cost be with perfect information. It'll still be that same number, just the difference between, again, the wage with uncertainty and the wage with certainty. Well, first let's take a look at how did we solve for that wage with certainty. Well, with certainty we said, okay, well the utility that we get when we consume our wage with certainty minus the cost of hard effort, well, that had to be equal to our reservation utility. Well, then we can say, okay, well, we can add CH to both sides and solve that the utility with certainty, our wage with certainty plugged into our utility function, had to be equal to our certainty equivalent plugged into our utility function plus that disutility of effort. So we're going to add it to both sides. And what this is saying literally is the amount that we are happy at our job with certainty, when we're getting paid with certainty, that wage that will get us that amount happy has to be equal to the same amount that we were happy at our other job plus this cost of effort that we have to have at our job. So again, this was in units of utility. Well, VH is in units of dollars. So what we need to do is we need to figure out how to put VH into this problem, and we know that we need to take out the utility aspect of this. So this line is saying that the wage that we pay at our job with certainty is going to be equal to the certainty equivalent, or the wage that we pay at the reservation job, plus some dollar amount to compensate for that hard effort. So we've successfully put in VH, and all we had to do was get rid of the utility part of this equation. So now that we've successfully put in VH, we can now solve this problem. Again, remember with uncertainty, the cost was, well, F% of the time we'd expect to pay the high wage, 1 minus F% of the time we'd expect to pay the low wage. So this was the expected wage with uncertainty. The extra cost due to moral hazard, well, that'll be just the cost with moral hazard minus the cost without moral hazard. And we can simplify that and plug in for WC. Now that we've plugged in for WC, we've already gotten the right answer. We just need to make it match an answer choice. So from here, we notice that in the answer choices, we don't see WL anywhere. Well, from the last question, we remember that WL is actually equal to CE. So we can make that substitution and plug that in. Well, again, the only thing I notice we can do is we can distribute through the 1 minus F to the CE. So we do that, and we see that we have CEs that are going to cancel. So we can cancel those CEs. And the last thing I see we can do is we can distribute out or factor out this F from each WH and CE. And this gives us an answer choice on the test. So I know that when you look at those answer choices, it seems impossible or it seems very hard. But if you remind yourself that it's all doable, you just need to, in this case, leave everything in notation and do the same steps that you would if you had math. I promise you, you can get these questions right. Just have faith.